Have you ever just looked at an AI-generated image and thought, how in the world does a computer come up with that from just a few words? I mean, it really feels like some kind of magic. But the secret, it turns out, isn't magic at all. It's this incredible idea from a research paper way back in 2015. And today, we're going to dig into that paper and uncover the physics-inspired idea that, honestly, laid the groundwork for the entire generative AI world we see today.
So let's just start with a question that sounds completely backward. What if the key to teaching a machine how to create something beautiful, something structured, was to first teach it how to systematically, piece by piece, destroy it? I know, it sounds nuts, right? But that is the exact idea we're going to unpack.
All right, so to really get why this was such a big deal, you have to understand the wall that AI researchers were hitting before 2015. They were trying to build these models that could actually understand and generate really complex stuff, real-world data. But they were kind of stuck in what you could call the generative dilemma. And this slide really nails the problem they were facing. See, on one hand, you had these pretty simple models. Think of like a basic bell curve. They were super fast, they were easy to work with, but they just could not capture the insane richness of something like a photograph. And then on the other hand, you had these unbelievably powerful, flexible models. I mean, in theory, they could describe anything, but trying to train them or even just get one single sample out of them was just computationally intractable. It would take, forever.
So where did the breakthrough finally come from? You'd think computer science, right? Well, nope. It came from a totally different world. Non-equilibrium thermodynamics. Yeah, researchers started looking at how physical systems, like gas moving around in a box, go from a state of order to a state of disorder and back again.
And this quote from the paper, it just perfectly captures their big light bulb moment. Systematically and slowly destroy structure, then learn a reverse diffusion process that restores structure. Think about how wild that is. Instead of trying to build something complex from scratch, from nothing, they decided to start with the perfect thing, break it, and then teach an AI how to put it back together. And this whole process of controlled destruction, it has a name. It's called a diffusion process. The best way to think about it is to imagine a perfectly sculpted sandcastle on a beach. The diffusion process is like the wind and the waves, just slowly, grain by grain, breaking it down until all you have left is a shapeless, random pile of sand. You're going from something incredibly complex and ordered to just simple, boring noise.
Okay, so that's the big idea. But how does it actually work? How do you use destruction to create something new? Well, it turns out to be this really elegant two-part dance.
It's all right here on this slide. First, you've got the forward process. This is where you take your perfect data, could be an image, a sound clip, whatever, and you just start adding a tiny bit of random noise. And you do it again and again, over hundreds, maybe thousands of little steps, until all that's left is pure static. Then comes the clever part, the reverse process. This is where the AI comes in. You train it to look at the noisy data at every single step and predict the tiny bit of noise that was just added. Basically, it learns how to perfectly undo the damage, one little step at a time. So to make this super clear, let's look at this Swiss roll from the paper. This is our starting point. This is our perfect, beautifully structured data. You can see the pattern plain as day. And now we start wrecking it on purpose. We apply that forward process. We add a little bit of random noise, then a little more, and a little more, over and over again. And what you get is this. The beautiful structure of that Swiss roll just dissolves into this random, formless cloud of points. We've turned our perfect data into simple noise. And here is where the magic happens. The AI is trained to do the exact opposite. It starts with just a random cloud of dots, like the one we just made. And then, step by step, it carefully removes just the right amount of noise in just the right direction to perfectly rebuild the original Swiss roll. It has learned the secret roadmap from total chaos back to perfect order. So you might be looking at that and thinking, okay, that's a cool party trick for a 2D graph, but so what? Well, the so what was absolutely massive, because this same technique could be used on incredibly complex, high-dimensional data, like images. And what's really powerful here is the scale. We're not talking about a handful of steps like in older deep learning models. This diffusion method allows them to train models with thousands of layers or time steps. And that lets the AI learn things with an incredible level of detail and nuance. So what can you actually do with all this?
Well, check this out. Denoising. The paper showed how the model could take a really corrupted image, like this photo of a cat with just a ton of noise added to it, and clean it right up. Because it learned the path from order to chaos, it can figure out the most likely path back, and the result is this remarkably clear picture. It's amazing.
But it gets even crazier with a task they call inpainting. The researchers took this picture of tree bark and just cut out a big square right from the middle. Then they asked the model to fill in the blank. And because it had learned the underlying structure of bark, it didn't just smudge the pixels together. It generated brand new, plausible textures and patterns that fit the rest of the image perfectly. And look, this wasn't just some, ooh, that looks nice kind of thing. They had the hard numbers to back it all up. When they tested it on this really complex image data set called dead leaves, their diffusion model got a way higher score than the previous state-of-the-art model. A higher score here is better. And they didn't just beat the old record, they smashed it. This was proof that the method really, really worked. And so, yeah, that 2015 paper kicked off a genuine revolution. The ideas we just walked through became the direct ancestors of the incredible diffusion models we see everywhere today. We're talking DALL-E, Midjourney, Stable Diffusion. Their DNA goes right back to this paper. So why did it take off like a rocket? Well, because it just solved so many headaches all at once. The models were super flexible, you could get really high-quality samples out of them, and suddenly tasks like denoising and inpainting became pretty straightforward. It just gave everyone this powerful, practical framework for making AI that could generate things. So this entire journey, from a simple little Swiss roll to photorealistic art, it all started with that one completely counterintuitive idea: learn how to create by learning how to reverse destruction. And it just leaves us with this huge question for the future. Now that we've found a way to teach machines how to create order from chaos, what in the world are we going to ask them to build next?